Hello and welcome to my tutorial on percentage yield. Now, percentage yield is used in chemistry to see how much of a product is formed when you put a certain amount of reactants in, and it's also used to identify which is the limiting reagent as well. So if you make a balanced equation like any one, let's take Mg plus O2 all goes to 2 MgO. You'd expect if I put 4 grams here and 8 grams here, then all of it would make magnesium oxide. But in reactions where there would be more than 2 products, it's very, very different. So if we take a look at some of these organic reactions, we can use this formula: percentage yield equals the actual amount in moles of the product. So we need to take the MR of the product in the balanced equation and then put it over the amount in grams of that product. Sorry, the other way up. The amount of grams of the product, so grams over MR is moles, and the theoretical amount, i.e. if I put 8 grams in, then 8 grams should come out. So we'll just have to go that quickly. So the questions is: a student prepared some ethanoic acid CH3COOH by heating ethanol C2H5OH with an oxidizing agent. The student reacted 9.2 grams of ethanol with an excess of sulfuric acid and potassium dichromate, and the student obtained 4.35 grams of ethanoic acid. So we need to calculate the amount in moles of ethanol that will be used. So if we have 9.2 grams of ethanol, we put that over the MR of ethanol, which is 12 plus 1 times 3 plus 12 plus 16 plus 16 plus 1, which is 46. And then we get 0.2 moles. And then if we have a 1-to-1 ratio in this balanced equation here, this is a 1-to-1 ratio between the reactant and the product. I'm forgetting the oxidizing agent for the moment. So the 1-to-1 ratio would be exactly the same: 0.2 moles on this side and 0.2 moles on this side. So when we look at step 3, finding the actual amount of the ethanoic acid made, then we would use 4.35 4.35 over 60 to get 0.0725 moles, and then you would divide that theoretical amount of moles over the actual amount times 100 to get a percentage output. If you're done it the wrong way up, you will get a very silly percentage. If you get a percentage like this, then you are doing it the right way up. So it's a quick reminder: actual amount over theoretical amount in moles of the product. So if we look at another example, a student prepared propyl methanoate in this reaction. So propanol plus this plus methanoic acid, so it makes methanoic acid and water, and then we need to calculate the amount of moles of propanol, 3 over 60, which is 0.05 moles. And using the equation, we need to determine the amount of theoretical moles. So 0.05 moles, since it's a 1-to-1 ratio. The actual amount of propyl methanoate would be 1.75 over 88, which is 0.01999. So the percentage yields would be 0.0199 over 0.05 times 100, and we get 39.8%. So we actually used the amount of propanol over the amount of propyl methanoate, and the limiting reagent here is this reagent here. It's the chemical substance, and it's a substance in a chemical reaction that runs out first, and this limits the amount of product we can get from a reaction. So I have a couple of questions here that I've yanked out the textbook. These are the two examples from the textbook that I used before, but I would like to draw your attention to these particular purple sections of the textbook. Spreads 162 to 163, as for quick revision. It really does help you. It goes through all the steps very nicely, and it even talks about limiting reagents as well. So if you are stuck and you need a little bit more guidance, then use these two pages, 162 to 163 in the textbook. So questions now. If we have 3.925 grams of 2-chloropropane and that reacts with an excess of aqueous sodium hydroxide, 2.955 of propan-2-ol is formed as shown in this equation. We need to calculate the percentage yield of propan-2-ol, which is this here. And ethanol reacts with ethanoic acid to produce an ester in water as shown in the equation below, this one. 5.5 grams of ethyl ethanoate is produced from 4 grams of ethanol and 4.5 grams of ethanoic acid. So here, ethyl ethanoate, we need to calculate the percentage yield of ethyl ethanoate. So I'll give you a few seconds to pause the video and have a go at the questions. Okay, so we'll have a go at this. So for question 1, read out the balanced equation again because it's always nice to. We now know we have a 1-to-1 ratio, always a good start. Now I have worked out the amount of 2-chloropropane, which is this compound here, lined it up with the compound, and the molar mass is, in case you get the molar mass wrong, it is 78.5, and we get 0.05 moles from this calculation, and the amount of ethyl ethanoate is 0.04925. So we use the equation again. Actual amount over theoretical gives us 98.5% atom economy. Now the closer it is to 100%, the greater the yield our reaction has. So if we have a very low yield, like 40% or lower, then we have a very shoddy reaction. We need to change the reaction or increase the amount of limiting reagent that we use in order to increase the yield. But this one is very, very good, as we don't waste a lot of resources. So if we look at number 2, 4.5 grams of ethanoic acid, 12 plus 3 plus 12 plus 16 times 2 plus 1. Again, I will write the molar mass down, so not 13, 3 plus 12 plus 16 times 2 plus 1 is 60. Yep, 60. And that gives us 0.075 moles. And then the actual amount of ethyl ethanoate, we get 88 for the molecular mass, and we get 0.0625 moles. And then again we use the equation actual amount in moles of product over the theoretical amount. We times that by 100 and we get 83.33%. Okay, if there's any other examples you would like, then I will try and find some more examples, as this is a very important part of the exam paper. Hopefully during past papers they will come up more as I go through each past paper, but for now, thank you for watching, and leave a comment section in the comments below if you want some more help, because it is important to appreciate this, as in A2 you get to use this a lot more.